Welcome to the new series of Slick Aviation. In this series I show you how to design and model planes in SOLIDWORKS. To make things interesting I used AI to help me design the new UAV. Moreover, I will actually build this plane in real life. What you see on the screen is my old design. Let's dive into the new design. I will use Google to come up with a new design. Google asked me some basic questions, but I will slap it with some heavy questions off the jump. I want to build 4-meter UAV fixed wing. AI basically said that it won't be easy. It told me to define the mission, payload, flight profile, and kindly reminded me that this kind of business is regulated by law. AI suggested all the steps needed to build my plane, and of course it mentioned that we need some CAD software. First, I asked AI to suggest airfoil type for long endurance flights. AI proposed some Epler and NACA airfoils. It also suggested that one single profile is not optimal, and it's better to have 3 different sections. I chose NACA profile and got my answers right away. At first, AI chose NACA 23012 for the wing root, NACA 4415 for the midspan, and NACA 65421 for the tip. It wants the thick and strong part of the wing to carry the most, and it wants the wing tips to be forgiving with stall. Smart! Next, I asked if washout is something to consider. I guess it figured that I want a tapered wing from my previous searches. So it told me that 2 to 3 degrees of washout will help preventing tip stall. Of course it reminded me that twisted wing will be more draggy. I also asked how much taper is suggested. AI chose 0.45 taper ratio. It said it is good for lift distribution, structural reasons, and some other complicated stuff. It also suggested to calculate the wing chords next. But I had some other questions. I asked about the power plant needed for this big plane. I said 30 kilograms is the total weight. It listed only 4-stroke engines, 120 to 170 cc. I guess starting with 80 cc 2-stroke would be okay. AI even suggested some specific brands, but I didn't bother to check them out. Next, I asked about the wing area. AI came up with something really big. I guess it wanted the plane to be able to fly really slow. 1 meter chord at the wing root is absolutely too big. So I asked to add flaps to the design and increase the wing loading to get smaller but faster wing. AI liked the flap idea. But now the 3-section airfoil changed to only 2 sections, NACA 4412 root to midspan and NACA 65421 at the tip. Next, I asked to calculate the stall speeds for flaps down and flaps up configuration. AI said 50.3 km per hour with no flaps and 39.7 km per hour with flaps down. I decided that we can be a bit faster than that and asked AI to increase the wing loading some more. AI said it's okay to load the wing more, but I should not forget that the flaps are very important in this case. I also asked to calculate takeoff and landing distance for this design. AI said takeoff roll is 33.6 meters, which sounds about right, but the ground roll of 255 meters seems way too long. I changed the scenario and assumed that we have burned 10 liters of gasoline, and now we try to land again. AI still claims 191.4 meters. If that's the case, we will need brakes. Next, I asked about wingtips. AI said yes for efficiency, and it warned me about complexity of making those. Google offered 3 types: blended, fences, or raked. Blended wingtip looks and performs best. I asked how to size the flaps and ailerons. 25% of local wing chord for the control surface, and more or less 50-50 span-wise divided between aileron and flap. Finally, I asked for servo sizing. 28.8 kilograms per centimeter for flaps and 19.6 kilograms per centimeter for ailerons. Sounds about right and also expensive. I realized that I don't want to use all of the wing for control surfaces. So I asked AI to exclude 20 inches of the inboard section. AI understood me well and did all the adjustments. That's enough details, let's get to work. I find a website for each airfoil generator. I click Send to Airfoil Generator. I check the parameters from the AI design and enter those to the plotter. I click Plot when ready. Then I click CSV file of coordinates to get it downloaded. I do the same to the wingtip profile, and I remember to add washout, -3 degrees. I open the CSV files with Notepad. I delete extra information so only curve coordinates are left. I also need to add third dimension for SOLIDWORKS to read the file. So I add 0.0 value to each column. Finally, I save the files as .txt format. I create a new part in SOLIDWORKS. I click Insert Curve, Curve through XYZ points. But wait, I forgot to change the unit system first. In bottom right corner I change it to millimeters, grams and seconds. Then I insert the curve again. And here we are, the shape of the root section is here. Click Sketch on the front plane. Highlight the shape of the curve and select Convert Entities. Now I close the shape of the curve by drawing a line. I draw a construction line going vertical through the end. I also draw a construction line tangent to the leading edge. Draw a point on the construction line and then select the curve, the line and the point and set the right relations. Hold Ctrl to select all 3. Add a dimension to make sure the size is right and save the file. The dimension is driven because of the points of the curve are defined by our text file. Now I create a new file and repeat the process for the wingtip profile. Just to be sure, I check for the 3 degrees washout by drawing the lines and measuring the angle. Create a new part again. Make front plane visible and drag it while holding Ctrl. Create parallel plane offset by half wingspan. Note that you can enter equations into SOLIDWORKS input boxes. You can also type what unit of measurement you want to use. As you see, I didn't write millimeters in the box and it set it to inches by default. It's easy to fix though. I create a new sketch on the front plane. Then I enter the sketch of our wing shape part, select all and copy the sketch with Ctrl+C. I come back to the new part and paste the sketch with Ctrl+V. I add the dimension again to make sure I don't change the size while moving the sketch around. I make the leading edge coincident with the sketch origin. Then exit the sketch. Next step is to draw the wingtip profile on the other plane created before. Create a sketch and copy and paste it from the wingtip part again. I want the taper only from one side, so I set the origin coincident with the leading edge again. There we go. I exit the sketch and I'm ready to perform a loft. Go to Features, Lofted Bow Space. Select the two sketches and press OK. We have the basic shape of the wing, but this is not what the AI asked for. AI said that from the root chord to the midspan we have to have the same profile, and then from there on the profile will transition to the wingtip profile. So we need to do some changes. I need to go back to the plotter to get the cross section for the midspan. I calculate the average of the chord length to get the midspan chord. I generate the plot for NACA 4412 profile and repeat the whole process again. I create one more plane for the midspan. I rename the planes for clarity. Then I create a new sketch on the mid-plane. I paste the midspan profile. Finally, I perform two lofts to create the wing. I also mirror the result to see the full span. That's all for today, and more coming soon.